Good morning, all of you. And here is a problem from calculus. And this can be asked equally in mains as a technical question or in advanced both. So let's try this question. S is a set of all function f belonging from 0 to 1, which is the domain, to codomain is R. Fx is continuous. So fx is a continuous function which operates from the window of 0 to 1. It can give any output, right? So it operates from the window of 0 to 1. It can give any output. It's continuous. So you can't take function as 0 to 1 as something like this. So this is not allowed, right? This is not allowed. We have to find maximum value of the integral for all such function f belonging to set S. Now the first thing is the function f of x is not known because there can be infinitely many functions. So let's say if I take a function from 0 to 1 as just 0, for f of x equal to 0, this integration will give 0 as the answer. If I take it 1, let's say, so if I consider f of x to be 1 from 0 to 1 this window, then the integral will be x to the power 2024 minus x to the power 2023 dx from 0 to 1, and that will give me the answer as 1 by 2025 minus 1 by 2024. So among all such functions, we need to maximize this. Now, well, the standard way of doing this will be to maybe, since I can't use Leibniz rule over here, and neither I can directly differentiate because it's a constant of differentiation. So if you want to use Leibniz, you have to use partial derivative. So I'm not going into that. But here is a scheme, and a good way of dealing with this situation. So probably we can take common. So square. So by taking minus common, minus f square minus x times of f can be written as minus f square minus 2 times x over 2 into f. That demands x square by 4 minus x square by 4. Hence the given expression can be written as x square by 4 minus f minus x by 2 whole square. Because you can clearly see the expression till here is f minus x by 2 whole square. So that can multiply with negative to give this answer. Hence I can write the given integral as x to the power 2023 times x square by 4 minus f minus x by 2 whole square dx. Now what is variable is this part. So if you want to maximize the integration, I must minimize this expression, right? Because f is the only function which is changing. So this part is variable, and clearly since it's non-negative, so the minimum value will be when f of x is going to be x by 2, which means the function is nothing but linear from 0 to 1. So under this condition, this quantity will simply die out, and the value of integral I'm going to get is 1 by 4x to the power 2025 dx, which will give me 1 by 2026 times 4. And that's the answer for this problem. So hope you get this question nicely. So let's try this question. We have been given two parabolas, and it's known like these two parabolas intersect at 4 points which are concyclic. We have to find the radius of the circle. So P1 and P2, so P1 represents upward parabola. P2 will be somewhere the parabola opening towards left, having axis along or is parallel to the x-axis. And now let's say they intersect at 4 points A, B, C, D. And I need to find the equation of circle passing through A, B, C, D. Now it feels difficult because the blind way of solving will be to plug x in the first expression, and that will give me biquadratic, and that's expected. So hence I have 4 roots. So let's say this point is x1 comma y1, x2 comma y2, x3 comma y3, and x4 comma y4. And finding this 4 root might not be so easier, because even if it is all real, of course, because the question has mentioned, it will be maybe the bad numbers. And what is interesting over here is directly I can find the equation of circle, because we can see if there is a circle passing through all these points, so any point on the circle x1 comma y1 must satisfy this both parabolic equation. So what if I add both of this expression? So we'll get y plus x equals x square plus y square minus 15x minus 9y and minus 55, and which gives me x square plus y square minus 15x minus 9y. Definitely a circle, but we don't know as of now whether it's a circle over here or a circle passing through only D, or is the circle which actually I want passing through ABCD. Now my claim is definitely the circle passing through ABCD. The reason being, since the point A will satisfy both the equation of P1 and P2, hence point A will satisfy the sum of these equations. Hence this circle, whatever it is definitely passing through point A, x1, y1. It is also being satisfied by point B, x2, y2. It's also satisfied by point C, x3, y3. And it is also satisfied by point D, x4, y4. So definitely with 4 points which are on the same line, there is a unique circle over here as mentioned in the question. So that circle is no one else apart from this circle. So this is a way in which smartly we can solve the problems. Here wanted by points in R. Now one way of clearly looking at the problem is we can see x cannot be negative because this expression is entirely strongly positive or equal to 0, so x must be positive, which means whatever graph I'm having, this inter is not to this zone is not to inter, right? So we'll have graph in this region and this region. From the symmetricity of expression, if any point x comma y belongs to the graph of R, and definitely x comma minus y will also belongs to graph of y, because the expression is symmetric along x-axis, because the expression is not going to change, will replace x with xy. So just I'll be dealing with the graph in the first quadrant. So let's see this. The more technical point is what is written over here can be decoded, and this kind of idea is already asked in JEE once. It's a nice problem based on those ideas. You can see we have terms here like half times mod of a plus b plus mod of a minus b. That's the structure of terms in LHS as well as RHS. And if I call this expression as, let's say, some function of a and b, so let's check what does it mean. So if I'll take a case a is more than b, f half of a plus b plus a minus b, which gives the value of as a. So it's basically the maximum of a and b. Okay, for a and b we are getting a, which is max of a and b. Similarly, if a is less than b, it will open as a plus b. I'm assuming a and b is both positive quantities. It's opening as a plus b plus a minus b. So that will be b minus a, and now this time a gets cancelled and we have b as the answer. That means this expression is picking up a value of a when a is greater, it's picking a value of b when b is greater. So precisely it's nothing but maximum of a and b. So that's how you define max of a and b. Here a is replaced with 1 and b is nothing but 2 mod y, and since both is positive, hence this works, right? So the given expression can be simply written as, in a clever notation, it's max of 1 comma 2 mod y is less than equal to x is less than mean of 7 comma 8 minus 2 mod y. And exactly in the similar way, I am leaving up to you to show like this expression is precisely half times now mod a plus b minus mod a minus b, and this will give mean of a and b, right? So now we have to graph just these two expressions, and which is not difficult to graph because we can graph y equals one line, right? When these two will be equal, that will give mod y equals half. So y equal to plus minus half. We have y equal to half line over here, y equals minus half. So that is the two lines we'll be getting over here. And out of this, I want x to be more than maximum 1 and 2 mod y, right? So if you are in this region, let's say here, clearly 2 mod y will be more, and if you are anywhere between these two boundaries, 2 mod y will be less. Let's similarly try the other way. So the equality case will be 7 equal to 8 minus 2 mod y, and it will give mod y equals half, which gives y equals again plus minus half. So for both of them I'm getting the same value, and now x should be lying between the max of this as well as min of this, right? So one of the graph that I'm getting is from here is y equal to, the line that I'm going to get is we have 4, and the reason will be y is greater than x. Equate when this is maximum. From here we can check the value as 8 minus 2 mod y is going to be x. So 2 mod y equals 8 minus x, since mod y equals 4 minus x by 2. So for positive case we'll have at x equal to 0, y equal to 4, right? So roughly the graph of this entire region in the positive, for positive y will be this region, and I can just reflect for the negative, and this total area that you are gonna get is will be 15, and the answer for this problem is 15. So now you can determine the values of these expressions. So I hope